Evening. Welcome to the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and this evening, I'm going to show you how a project is planned and delivered. Let me go ahead and share my screen. Now, this project is for my TLI 314 class at Purdue University. And if you're going to do some research, you can learn from what I've actually done. This is a real project. Okay, now, what I'm going to be doing, this is a project, and I'm going to talk about the number of stops to minimize total costs for a rail line to the New Jersey Transit. Well, it's from the New Jersey Transit to the Atlantic City line. And when I mean optimal number of stops, we're going to talk about stations. Now, I'm going to deal with my overview. I'm going to give you a little background of the project, the methodology, the results and validation. Will there need to be future research? 5 phases. And of course, constraints. Now, again, when we deal with the background, here's a map. And what you have New Jersey Transit. It's a passenger rail system. New York City, Philadelphia, goes all the way to Atlantic City. What we want to do is we actually want to construct the last segment or section of rail line from Bayhead to Atlantic City. Now, the background and motivation for this project is, again, the existing New Jersey Transit line crosses New Jersey from Philadelphia to Atlantic City with no other direct transfer to other NJ Transit lines. Now, again, there are approximately 33 million people throughout the tri-state area that visit Atlantic City. Now, the tri-state area, when we deal with Atlantic City, is Philadelphia, South Jersey, and Delaware. Now, again, victors, and they are victors because they're visitors, because the visitors are the ones who are the tourists who help the economy of Atlantic City. So they play an important role. However, there's a high volume of drivers that contribute to the congestion and poor level of service of New Jersey's highways. Now, we have methodology. And phase 1 is the environmental feasibility study and cost to build. Now, when we deal with constructability, it's how will the project be constructed? What are the best management practices that will be used during construction operations? Well, when we deal with projects, we have to deal with the environmental factors, such as wetlands, emissions, endangered species, land use, and of course, noise pollution. Now, of course, here's a map. And when we deal with methodology, we also have our proposals. Right now, this is the existing line. Goes all the way from Philadelphia to Atlantic City. Now we have 2 proposals. Number 1, we want a line to come from Point Pleasant all the way down to Absecon to Atlantic City. That's alternative 1. Alternative 2, a line from Trenton to Linderwood, and then you would transfer from Linderwood all the way down to Absecon, then to Atlantic City. Now, again, when we deal with the methodology, just like the phases, they're alternatives. So basically, when we deal with alternative zero, there's no build at all. Use current infrastructure, such as building facilities, railways, and highways. Now, alternative one, just minor improvements for railway from Trenton to Atlantic City via Philadelphia. Now, the total length is 73 miles. Alternative two, you build a new rail system from Bayhead to Obsescon, total length 58 miles. Again, let me drop in a few numbers for you. With alternative zero, no build, we're going to use the current infrastructure. So here's what we have. We have the Brigantine Connector, 330 million, the Atlantic City Expressway, 48 million, six-story parking garage, post AMS 15 square foot building, terminal renovations. Operations cost for buildings, maintenance building, maintenance cost for roadway. These are already existing, and that's going to cost 428 million. Again, you're going to do projects, have some numbers. Everybody know what the benefit cost ratio is. Now, when we get into the improvements, you see you have to deal with leases, rolling stock, casino revenue transfer program, and rail infrastructure. As I move on, rail support facilities. Now, that's just for minor improvements. That's alternative one. It's a 73-mile length, and the total cost is $451 billion. Now, when we get down to alternative two, just build a brand new rail system from Bayhead to Obsescon, total length 58 miles. Well, you know you have to have the materials, and they're going to be pretty costly. Your track, your rail passenger facilities, right of way, park and ride, engineering services, and passenger vehicles. Now, here are all the numbers that I came up with, and all of these numbers were estimated. You're going to have bridges, track material, maintenance of railroad. And when you look at everything, it's actually going to cost less to build a new facility. As we look at three different alternatives. Now, when we rank alternatives, the no build, total cost, 428 million. If we upgrade the existing rail system, it's 451 million. Then when we go to the second alternative, just build a 58-mile new railway system, come up with 354 million. Now, when we deal with any type of project, you want to find the best economic solution. So what I've come up with on this project is alternative two. And if you look at alternative two compared to alternative zero, that's a good, I'm just going to round numbers off here, right around 74 million you're saving. And if you look at alternative two compared to alternative one, that's a savings of roughly $97 million. Now, here's why alternative two is the most economic alternative. Number one, it costs less to build a brand new facility than to upgrade existing facilities because the new facility isn't incurring costs since it is in operation. Now, also, A new system reduces traffic on highways and wait times at existing rail systems because it is shorter in length and you don't have to stop in Philadelphia or transfer. It also gives one location an advantage over other locations by attracting residential and commercial development that would occur elsewhere within the region. This is known as economic transfer. It will create more jobs, ridership, and revenue for NJ Transit. Therefore, the citizens or residents can spread the money, or the government, again, New Jersey Transit, private and public firms, municipalities, they can basically spread the money to finance upgrades to the existing infrastructures, such as bus terminals and other existing rail systems. Yeah, so if you put in a brand new system, you're still going to have upgrades to do at other points where citizens go to catch the train. And the bus stations are the areas that are going to need to be upgraded. And of course, they're going to build new facilities where you can park and ride. Also, a new rail system can increase the overall productivity by reducing total local transportation costs, including costs to customers or consumers, businesses, and governments for vehicles, parking, and roads. And also provides a catalyst for more cluster development patterns that will provide economies for agglomeration, which in turn, it will reduce the cost of providing public services and increases productivity due to improved accessibility and network effects. Now, although these productivity benefits are difficult to quantify, they can be large. Just a few percentage increase in property values. So basically a few percentage reduction in automobile and parking costs and a few percentage increase in business productivity in a community can total hundreds and millions of dollars. Now, again, here's all the information, how I came up with all of my factors, and I'm dealing with optimization. And these are the variables. I'm in the math. So I'm going to use all these variables to figure out cost of ridership per day, local cost per year. And there are also constraints. And constraints will be coming up later. It's going to be a different kind of constraint. But you have to have your constraints, like your distance between stations, your number of feasible stations. You can never forget that with every project, there are going to be constraints. Again, here's our map right here. Here's Bayhead. This is the 58-mile stretch that I chose because it was cheaper, all the way down to Obseska. And this is along the beach areas of New Jersey. And there is a lot of money, and I've been to these areas. And New Jersey is one of the highest tax states in the nation. It is one of the highest. So you know, right along the beach areas, there's a lot of money. And this railroad will keep people off US 9 and the Garden State Parkway. And of course, the methodology. How did I come up with everything? Well, I utilized National Household Transit Database to estimate the percentage of population uses with commuter rail. So basically 2% of populations utilize commuter rail in persons per daily trip compared to other modes of transportation. I have to consider population of surrounding towns within driving areas using GIS isochrones. I'll show you what an isochrone is in a minute. And added the portion of these populations to the drivers to Atlantic City to estimate potential ridership of the line. These are isochrones right here. And these isochrones are all of your townships. Like number one is Bayhead Township. Number two is Brick Township. Number three is Toms River Township. Number four is Lacey Township. Number five is Barnegat Township. Then you have Stafford Township, Eagleswood Township, Port City Township, Galloway Township, and then Absiskin Township. And these isochrones, that's where the proposed stations are going to go. Now, again, you're in Monmouth County, Ocean County, just short of Burlington County, and then Atlantic County. And then here's a graph with the total population to be considered. So there are a lot of factors that come into play when we're developing a project. Population, we deal with the number of people per township. And you see most of your people are going to go right up to Brick Township. Again, I'll leave this information up so you can check it out for yourself. And it'll also be on my LinkedIn page. Okay, now, later on, I'm going to talk about some constraints, but I have to talk about assumptions because it's very important. This is part of the methodology. Well, the demand density will be based on population data from census as well as historical data. Then you're going to have passengers' use of the rail line as a round trip, number of passenger seats. A user is willing to drive an average of 10 minutes to a train station in order to park and take the rail. The average driving access speed is 25 miles per hour. Therefore, a circular isochrone of radius of 4.17 miles is used. Then we're going to get into the values per user weight, access, travel costs. And then we must understand the user's preference. And here are our results. I'm up with the numbers, total cost per day, $11 million. And all these numbers came from the variables that I had up earlier. We figured in the error, and that's what we come up with. And here are constraints right here, your demand and your capacity. Number of stations, number of stops. So basically, with all this information that I've given you, we're going to come up with 8 to 9 stops. But again, because of the estimate of cost, I actually chose 8 stops instead of 9. And this is our final proposed layout from Bayhead to Absiskin. And here's your isochrone. It deals with your population area, different colors. Now, with all this being put together, there will be future research because of population growth, level of service on highways, ridership on existing railways. Will there be another project in the planning stage? Will our alternative break even during a 3 to 5 year period? They have to come up with a benefit cost analysis against the existing rail infrastructure from Trenton to Philadelphia to Trenton to get the most benefit at minimal cost. And we deal with the politics, financing, economic impacts, which are also constraints, right-of-way concerns, issues, safety, and security. And then we have to collect real survey data to provide even a more accurate estimated ridership by utilizing utility functions such as the logic model. The model can also include estimated fare to determine if the line would be economically beneficial to New Jersey Transit and the state of New Jersey. And then we have to optimize a timetable with the optimum headway to further verify the feasibility of the line. Now, again, now we get into our phases. Now, one phase I have is, okay, identify the problem. Just as I mentioned before, population growth, level of service. Will there be a need for another project? Will another project be in a planning stage? And what are we trying to do? We're basically trying to reduce travel time for residents to get to Atlantic City from Philadelphia and New York. Now, where is the problem going to lie? With the New Jersey Transit Authority and the state of New Jersey, or the New Jersey Department of Transportation? Now, I will say this. In order for this project to succeed at phase 0, New Jersey has to come up with the money along with other municipalities. That's phase 0. Phase 1 deals with the government, Federal Highway Administration, private engineering firms. One must understand that all transportation projects are funded by the government. It's going to also depend on the demand of the product or project. Project will be a good product if it works. Now, when we deal with destructive behaviors, won't even include them in any team environment. Why? Because, as I mentioned before, their behaviors are destructive. They're impulsive thinkers, they're very emotional, and they're not going to understand the logic that's going to go into this project. And also, some of them may have big egos. So they're not going to be able to brainstorm. They might not want to hear anybody else's points of view. Now, again, what have I done? We've already explored. This is phase 1. Generating ideas of the options and benefits for this project. Let's move on to phase 2. Again, I can work with the private and public entities that really have a belief in this project. Again, when it comes to any type of project, this could also go as a constraint as well. The biggest issue with any project is how much it's going to cost, particularly the big projects. Who's going to design it? So we have to deal with the government agencies and private engineering firms. The government agencies are going to be doing the funding, but when it comes to designing of big projects, we need engineering firms that have the experience. And as part of a team, I will help get this. I will help with this project by offering my assistance, my construction knowledge, my design knowledge. And I will also provide suggestions on why this product, and it's a product, although it's a project, why it's needed. And as an engineer, I'll be ecstatic and excited to be part of designing this project. Let's set directions. Well, engineering firms have to bid for the planning and design for the project. Government agencies and private engineering firms, again, government deals with the funding, and we need engineering firms with the design experience. Got to select the right teams who will be committed to planning and designing of the project. Again, you got to select the right team members who will be committed to the planning and designing for this project. Now, there will be some issues along the way. Purchasing right of way, funding, and then there'll be environmental issues such as wetlands. So somewhere along, there are going to be permits needed. Again, somewhere down the line, there will be needed in the future because of environmental regulations. You got to have permits such as NPDES permits, Army Corps of Engineer permits, 404, 104, all kinds of permits. Again, when we deal with projects, we want to get product, you must understand the environmental regulations. That's phase 3. Phase 4. Well, with anything, there's going to be some stress. So let's provide stress management and mental health resources, and we have to maintain emotional well-being. And for careers, let's look at job market trends and, of course, professional growth, such as education. Now, again, who are going to be the individuals that are going to have a problem with this project? Environmental groups, residents, businesses, and maybe the government. Now, I can pull the emergency brake, but my team and I, again, we will continue to consider alternatives. And when it comes to dealing with any project, who's going to be on the leadership team? And if we have a leadership team, which we will have a leadership team, the senior leadership should first understand what changes are necessary and why they are needed. That's phase 4. As we're going to phase 5, the most powerful champion is going to be the local government and the citizens who want this project, because I believe it is going to help out many people in the state of New Jersey. Now, what about critics? There's always going to be a critic. Listen to their point of view, be patient. It takes time to change people's point of views. Sometimes you may, sometimes you may not. Now, I will say this. You want to resolve any project deficiencies? Document the requirements of the project. Create a clear project schedule. Verify the scope with stakeholders. Now, who are your stakeholders? Your stakeholders are generally your workers. You have stockholders and your stakeholders. Your leadership team on down to the design personnel, and you also have stakeholders within the government. Now, again, a project can be valued based on financial value, social value, innovation value, and of course, strategic value. And then we get into our constraints. Now, this is a different type of constraints. So as I break it down, we have an individual constraint, and that's problem-solving strategy. What is the problem, and why is there a need for the project? Now, the problem is there's congestion on the Atlantic City Expressway. There's also a lot of time that individuals have to use to go from Philadelphia to Atlantic City. Some may have to go to Trenton and then all the way down. That's a lot of time. That's a problem. And then how do we leverage the existing infrastructure? This is a society or a societal constraint. And then what about the laws and regulations? And that comes within how do we purchase property? There's a law. Eminent domain, regulations. And when it comes to society, who in society is going to oppose the project? There have been many projects that I know that have gotten canceled by certain individuals of society, some real powerful, like your environmental groups. Now, when it comes to technology, then you must understand, is the technology up to date? You have the computer systems able to handle the computer aided drafting systems? And then what kind of system or software are we going to use to keep our technology from being hacked? Those are technology constraints. Now, organizational constraints. Do we have the right people for the job? Do we, inside an organization, understand the strategy? How do we compete? What kind of organizational structure do we have? Do we have a horizontal, a correction? Do we have a vertical structure, or do we have a matrix structure? And then group constraints. Now, when we deal with teams, we have to brainstorm. And you have some people who think they know more than others and they want to do all the talking. Well, how do we leverage that? In other words, how do we manage different behaviors? Which comes to the question, if we can manage different behaviors, then we must achieve cohesion within the group, because everybody's not going to agree on a subject. So how can we get people together so they can be on the same page? And then industry constraints. We have the capital, the bid for projects. Are there too many constraints in the market for big projects, such as a recession, such as bankruptcy within the government, such as where's the tax money going? Or do we have other interests? Do we need the project right now? And then for our industry, how can we compete with other industries? Because in the construction business, there is a lot of competition. But there you have it. What I presented to you was a real project that I actually put together. Showed you the methodologies, showed you all the constraints, the costs, showed you some maps, the graphs, got into the methodology which dealt with the phases. Then I broke it down with, it's actually 6 different phases if you include phase 0. And I broke out the 6 constraints. Now, there are a lot more. In fact, one of the biggest constraints that you must think about, and it also goes with the phase on the construction side, is safety. So there has to be programs in place to make sure that workers are completing the work safely. Now, yes, you have safety inside your office as well, but working out in the field, particularly on transportation projects, you have to be safe. And safety is everybody's responsibility. And I thank you for viewing this content from the QCIS channel. And on this channel, you get a daily dose of science, technology, engineering, and math. And of course, if you want to get into some political and social content, you can check out my other channel on the 411 Talk Zone radio show channel. Now, if you cannot find the QCIS channel or the 411 Talk Zone radio show on YouTube, you can find both of those channels on Twitter. which is now X. Now, for the QCIS channel, since videos like this one that I just completed tonight is an educational video, I will also post that video on my LinkedIn page. And once again, thank you for viewing this content on the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.